Hello, fabulous students. Today we're going to take on in assignment 50, implicit differentiation. So implicit is a technique that I use when y cannot be written as a function of x. So if I have something like this, x to the third plus y to the third minus 9xy equals 0. And I'm politely asked to find dy dx. Well, so here's the thing about trying to find dy dx. Ooh, too much there. I can't solve this equation for y equals. The algebra doesn't exist to allow me to do that. So what I'm going to do is I'm going to take the derivative implicitly. And I guess the first thing I want to say before that is we've been doing implicit differentiation all along. We've been using chain rule all along. We just haven't noticed it. For example, let's talk about this. Y equals x to the third. If I take the derivative with respect to x at both sides, here's what I would like you to understand and recognize. Taking the derivative of this means taking the derivative of that outside function. Leave the inside function alone. Don't forget to subtract 1. But now, come back and take the derivative of the inside function with respect to x. The derivative of x with respect to x. Well, the derivative of x with respect to x is just 1. So we've been doing this, this chain rule thing for quite a while now. Well, what happens when I want to do the derivative of y to the third? Again, with respect to x. So I take the derivative here, and again, I can take the derivative of that outside. I can leave the inside alone. Don't forget to subtract 1. But now, listen, take the derivative of the inside with respect to x. So whenever I take the derivative of y to stuff, there's going to be a dy dx that shows up. Dy dx represents taking the derivative of y with respect to x, or even taking the derivative of this inside thing with respect to x. Okay? So when I look at a problem like this, and I'm asked to say, find the derivative, find dy dx. Okay, so the derivative of x to the third is 3x squared dx dx plus the derivative of y to the third, 3y squared times dy dx. Now, here's the thing. Did you just feel like, oh, why did he write that? We don't have to write that. No, you don't have to write that. But I think it's really useful in this discussion, in this conversation, to think about this not being strange, because this is what I'm really doing. I'm really doing chain rule here. I know in your brains you're doing power rule and bringing down that power and subtracting 1. But I'm thinking about chain rule here, and I'm thinking about the derivative of the inside with respect to x. Here that cancels out, and I can get rid of it. 3x squared plus 3y squared dy dx. But here I can't. Here I took the derivative of the outside, I brought down the 3, I subtracted 1, then I had to come back and take the derivative of that inside object, derivative of the inside with respect to x. Okay? All right, now what about this? Well, That's product. So I have to use the product rule. Some students like doing this kind of thing. -9, and then they do the product rule. Some students like bundling these together and doing the product rule. I don't really care what you do. Since I already have these brackets here, I'm going to do it where I leave the 9 on the outside and distribute it later, and I'm just going to look at the product rule here. This times the derivative of that with respect to x. This times the derivative of that with respect to x, plus that times the derivative of x with respect to x. Oh, well, that's just 1. Okay, so, and then on the other side, the derivative of 0 is 0. I need to distribute my -9 to both of these, and so it looks like I'm going to have 3x squared plus 3y squared dy dx minus 9x dy dx plus y equals 0. Now remember, we're looking for dy dx here. Okay, we're looking for dy dx. And that means I need to solve this equation for dy dx. So either I'm moving all the stuff that's not dy dx, or I'm moving all the stuff that is dy dx to the other side of the equal sign. So, and we'll come back and have a note about why does it matter or does it matter which side I push stuff on after we're done solving this. I'm going to move all the dy dx stuff over there. So I'm going to have 3x squared plus y. Isn't that 9y? Excuse me. Gotta go back here for a second. This dy dx plus y times 1. Yes, that's -9y there. Okay. So we move that minus y. And the dy dx stuff went to the other side. Okay, so then, why look, I could factor out a dy dx over there. 9x minus 3y squared dy dx. And since I'm solving for dy dx, I have to get rid of this stuff. It's all attached with multiplication. So I'm just going to divide both sides by 9x minus 3y squared. 9x minus 3y squared. There's dy dx. Now, if you want to simplify this, you can simplify it. Please don't cancel those x's or those y's. That won't work. But you could take a 3 out of everything. And so it would look like this. Now, remember how I moved all the dy dx stuff over there? Well, if you had left the dy dx stuff on the left side and moved all the not dy dx to the other side, then your answer would look like this. -x squared plus 3y over -3x plus y squared. Every sign would be opposite. So that if you factored a -1 out of the top and a -1 out of the bottom, and you had -1 over -1, you can cancel those out and you'd be looking at this other solution. Okay? All right, so that's implicit, and we're going to take 2 days to talk about it. Really, that's implicit, and we're just going to practice it a whole bunch so that you're comfortable with it. I think we should maybe think about practicing some more of that chain rule with product rule and chain rule with quotient rule that often troubles students as well. So we did that one. How about this one? There we go. X squared plus y squared equals 1. Can you do it? Can you try it? Give it a try. Pause the video, give it a try. Come back when you're done. Okay, welcome back. So again, I'm taking the derivative of the outside. I'm leaving the inside alone. I'm subtracting 1. and then I'm taking the derivative of the inside with respect to x. So I just have 2x. But then my plus sign, and I'm taking the derivative of the outside, leaving that inside alone. Don't forget to subtract 1. But I have to come back and take the derivative of that inside with respect to x. Derivative of 1 is 0. Okay, so I've got 2x plus 2y dy dx, and so equals 0. 2y dy dx equals negative 2x. And so I can end up saying that dy dx equals negative x over y. Now, curiously, when I see this differential equation, when I see this derivative, I've been doing this for a while and I say, oh, that's a circle. Because look, this is a circle whose center is the origin and whose radius, remember this is r squared, whose radius is 1. So, yeah, there's the derivative of my circle. Okay, how about this one? X squared plus y to the third equals 18xy. Give it a try, see what you get. Welcome back. Maybe this is getting a little easier. Maybe you're catching on, but maybe you're not. And so again, I'm taking the derivative of the outside. I'm bringing down that 3. I'm subtracting 1. I'm leaving the inside alone. Then I'm coming back and multiplying by the derivative of this inside, the derivative of the inside thing with respect to x. And on this side, ooh, look, it's product. Last time I pulled out the 18, let's make this go together. So 18x times the derivative of that, 18x dy dx plus the derivative of 18x is 18 times y. And then we want to get all the dy dx stuff on one side and the not dy dx stuff on the other. So 2x minus 18y equals 18x dy dx minus 3y squared dy dx. Don't forget to factor out that dy dx. You'll be left with 18x minus 3y squared. And on the other side, 2x minus 18y. So I want to divide both sides by this. To get dy dx by itself. Nice. Can't take out a 3 there. Okay, all done. Move on. Now, I will say that we will have to do stuff with these derivatives once we're done taking them, and we'll do that in a minute or so. Ooh, this one says find the second derivative implicitly. So 2x to the third minus 3y squared equals 8. So first derivative of this is going to be 6x squared. Yes, that's right. And then I come and I take the derivative of the inside with respect to x, and that's dx dx, which is just 1, so we never bother to write them. But over here, I bring down that 2, I leave the inside alone, and now I come back and I take the derivative of that inside with respect to x. And on the right-hand side, the derivative of 8 is 0. So I'm going to have 6x squared equals 6y dy dx. Divide by 6y. And so now I have that dy dx equals x squared over y. Now, what if, I know we're still going to do the second derivative, but I kind of want to stop here for a second. It's very hard to do, so I'm not going to do it there. Never mind. Let's just go on to the second derivative. Here's the first derivative. Now the second derivative means I take the derivative of this derivative. So if I'm taking the derivative with respect to x on both sides, I have a quotient here, and I have to use a quotient rule here, and I have to use the quotient rule here. So let's go use the quotient rule. Okay, quotient rule. I'm taking the derivative with respect to x of x squared over y, and I know that means low d high minus high d low, the derivative of the low with respect to x, all over low squared. Okay? Now, remember we said that dy dx was this? Look, see that dy dx? I need to get rid of it. The second derivative equals, and I don't want anything in terms of dy dx, so I have to replace that dy dx with x squared over y. And so I end up with 2xy minus x to the fourth over y squared. You can certainly tidy this up if you want. I'm going to multiply top and bottom by 1 over y squared. And so I end up with 2xy over y squared minus x to the fourth over y to the third. I guess I could take out that and that. Or I can have a common denominator now. Just be able to take that derivative. Though I guess maybe you should bother, because this is sometimes a free response question, but it's also sometimes a multiple choice question. And of course the multiple choice will always simplify. How about this one? 2y equals x squared plus sine of y. Get this one. Second derivative. Let's see what you get from the second derivative. Welcome back. So here, the derivative of a constant times the thing is that constant times the derivative of that thing. Here, derivative is 2x, x dx, but no, we don't write that, plus the derivative of sine, leave the inside alone, times the derivative of the inside with respect to x. Remember, we want to solve for dy dx here, so I'm going to move this over there and have 2 minus cosine y dy dx equals 2x, and so I know that dy dx equals 2x over 2 minus cosine y. Oh, but wait, this is just the first derivative. We now need to go and do the second derivative. The second derivative says, hey, you could use quotient rule here. I could use quotient rule, or I could also flip this up, 2 minus cosine y to the negative 1. And I just feel like that's going to be a lot of negatives, and I'm likely to make a mistake with that. So I think I'm going to lead with quotient rule. So the second derivative is going to be low d high minus high d low. The derivative of 2 is 0. The derivative of negative cosine is positive sine. Leave the inside alone. Then you want to multiply by the derivative of that inside thing with respect to x. Well, I'm looking for dx. No, I have that. Oh, right, that's the thing I have to substitute in. So when I have the second derivative, I don't want any of these little first derivative symbols sitting there. I want everything in terms of x's and y's. So what's that going to look like? Well, 4 minus 2 cosine y minus 2x sine y times 2x over 2 minus cosine y. And, you know, I'd probably leave it like that. Um, you could make a common denominator. You could write this as 4x squared sine y on top of that. Uh, but I think I'm just going to move on. All right. So if you haven't done one yet, please find the second derivative of our dear friend's circle. Hello, welcome back. So the derivative here, 2x, the derivative here, 2y, dy dx, the derivative here is 0. You know, it's funny, in implicit, people forget the derivative of a constant is 0. I'm not sure why that is. So, yeah, I would say be mindful of that. Solving for dy dx, I'm going to move the 2x over. 2y dy dx equals negative 2x. And then divide both sides by 2y to get dy dx equals negative x over y. Now, I want to find the second derivative. So what's the second derivative of this? I have to use quotient rule. Low d high minus high d low all over low squared. Remember, this is our dy dx, so it needs to go in there. So what would we be left with? Well, I'm going to have negative y minus x squared over y squared. Right, because that over y is this one. X squared. 1, 2, 3 negatives. Excellent. There's my second derivative. Hey, you know, we've been doing this implicit, but we haven't really talked about using the implicit. So remember how I said that this was going to be the graph of a circle centered at the origin with a radius of 1? Well, I'd like to know, find the slope at 0. Oh, at x equals 0. Okay, so now notice here, we've already solved for this, right? And we got negative x over y. In order to evaluate this derivative, it's not just an x value I need to plug in, but an x value and a y value. So I need to find the y value that goes with this. Well, we know our unit circle, and we know this is 0, 1. But I can also, and this is the way you're more frequently going to do it, plug that 0 in there and solve for y. So I get y squared equals 1, or y equals plus and minus 1. Oh, that's right, there's another one down here. Oh. So if I want to find the slope at x equals 0, I have to check both of these, and that means plugging in a 0 for x and a negative 1 for y, and a 0 for x and a positive 1 for y. Are we surprised to see a slope of 0 at those places? No, not at all. So instead, let me ask you the question. Find the slope of this thing at x equals root 2 over 2. And then I'm going to ask you an interesting question. Okay, welcome back. So we said that the derivative here was negative x over y. And I can plug this in for x, but I need to find the y value there. So I think I'm going to plug this back in here and have root 2 over 2 squared plus y squared equals 1. Well, when I square top and bottom, I have 2 over 4, which is 1/2. So I'm going to subtract 1/2 from both sides. And now I'm going to take the square root. Don't forget, when you take the square root of both sides, you get that plus and minus. And this will be the same as plus and minus 1 over root 2. And you know what that is when you rationalize top and bottom? Root 2 over 2. Oh, look at that. Okay, so, and are we surprised when x is positive root 2 over 2, we have two different y values? Well, no, because this is the unit circle, by the way, right? It's got a radius of 1 centered at the origin. And what we're saying here is there's this one where we have positive root 2 over 2 and negative root 2 over 2. But we also have this one where we have positive root 2 over 2 and positive root 2 over 2 there. So, but I do have the plus or minus, so don't forget that. Okay, so let's take a look. I want to find the slope at the ordered pair root 2 over 2, comma, negative root 2 over 2, and at root 2 over 2, comma, root 2 over 2. So let's see what happens with plugging in this ordered pair into this dy dx. So I get negative root 2 over 2 over root 2 over 2, and that's negative 1. So the slope at that point is negative 1. Yeah, I could buy that. And then if I plug in that other ordered pair, negative root 2 over 2 over root 2 over 2, a negative times a positive is positive, and I end up with positive 1. Can we believe that the slope over here is positive 1? Sure, I can believe that. But wait, I gotta ask you this other question. Ready? Didn't we know something last semester in trig about negative 1 or positive 1 for the pi over 4s? Let's ask this question. What's the tangent of pi over 4? Well, it's the sine of pi over 4 over the cosine of pi over 4. And that's root 2 over 2 over root 2 over 2, and that's positive 1. Huh. That's very interesting. There's something here, but I'm not going to talk about it yet. I'm just going to tease in that pixie-ish way. You should think about it. All right, now the application problems. This is the way you're often going to experience implicit differentiation on the exam. So x squared plus 2xy plus y squared equals 4. And I would like you to write the tangent at x equals 3. Okay? So I want to write the tangent line of x equals 3. X equals 3. Yeah, let's see how that goes. So, what information do I need to write a tangent line? I need a point. Right now I have half a point. And I need a slope, aka a derivative evaluated at that point. So, how do I find the y value? Well, let's take this x value and plug that in for the x's. So we're going to have 9 plus 6y plus y squared equals 4. And if we move that over, we're going to have y squared plus 6y plus 5 equals 0. And so that's y plus 5 and y plus 1 equals 0. And so I get y equals negative 5 and y equals positive 1. So these two places where x is equal to 3, one of them is this ordered pair, the other is this ordered pair. Nice. Now, I also need not just a point, but I need the slope. And we know a synonym for slope in our class is derivative. So, derivative of x squared is 2x, The derivative of this requires product rule, 2x dy dx plus 2y. And then the derivative of y squared is going to be 2y dy dx. And the derivative of 4 is 0. So I've got 2x plus 2y. Yeah, hold on, Nathan. I'll come back and talk about that. Equals negative 2x minus 2y dy dx. Divide both sides. I've got 2x plus 2y over negative 2x minus 2y. There's dy dx. If I factor out a negative there, you want to take out a negative 2, do you? Well, I don't want to. I'm just taking out the negative. 2x plus 2y, because look what I see on top and bottom. Huh. So, does that mean the slope is 0? No. That's negative 1. Well, that's very interesting. I didn't even get to the place where I plugged in the ordered pair. I just know that the derivative is always negative 1. The derivative is always negative 1. Oops. I feel like I've definitely done something wrong. Well, let's take a look. Yes, 2x, the derivative of that with respect to x, plus 2 is the derivative of 2x times y, plus 2y divided dx. And then I move those over. Yeah, no. Okay, that's weird. And then I have to write the tangent line. Well, writing the tangent line, no problem. I know the slope now is negative 1. So I'm going to say x minus minus 5, oops, y minus 5 equals negative 1, x minus 3, and y minus 1 equals negative 1, x minus 3. Stop and move on. But hold on a second. I kind of want to understand what's going on here. I think Nathan was thinking this is a perfect square trinomial, and that if we take the square root of both sides, we end up with x plus y equals plus or minus 2. And then I take the derivative implicitly. Derivative of this is 1. The derivative of this is dy dx. And the derivative of this is 0. And so I subtract 1 from both sides. I get dy dx equals negative 1. Ta-da! Which is kind of interesting, because that means at any point on this, my slope is negative 1. It's a constant slope. It's very interesting. Okay, how about this one? X squared minus 3xy plus 2y squared equals 10. And I want the normal line at 4, 1. Okay? Do you ever heard about a normal line? Remember, a normal is perpendicular to the tangent at the point of tangency. So, let's do the tangent line, because we just practiced that. And then when we're done, we'll do the normal line and see how similar they are. I've got an ordered pair. What's the other thing I need to write a tangent line? A slope. So I got to find dy dx at that point. Let's give it a go. 2x minus 3x dy dx minus 3y plus 4y dy dx equals 0. It would be really great if you could get that comfortable with implicit differentiation, which means you should practice it some more. Okay, I'm going to move this stuff to the other side. Actually, I'm going to leave these things right here, and I'm going to move this stuff to the other side. Why did I change my mind? I didn't want to write all that stuff over here. I will factor out a dy dx on the left and be left with minus 3x plus 4y. And then on the other side, these signs change. I have 3y minus 2x. Don't forget to divide both sides by this stuff so that you can get dy dx by itself. And remember, we want to evaluate this at 4, 1. So we want to evaluate this at 4, 1. We need not just the ordered pair, but we also need the slope at that point. Okay? So if I plug in, hey, be really careful. That's an x value. Lots of students are going to plug it in right there because it came first. Watch out for that. Okay, so I've got 3 times 1 minus 2 times 4 over negative 3 times 4 plus 4 times 1. Okay, so that's negative 5 on top, and on the bottom we have negative 12 plus 4 is negative 8, and so I get a positive 5/8. So I know my slope is 5/8. Yeah. And I'm ready to write my tangent line. So y minus 1 equals 5/8 x minus 4. All done. No problem. Piece of cake. But remember, I had originally asked for the normal line. And remember, the normal is perpendicular to the tangent line at the point of tangency. So I need the opposite reciprocal slope here. My perpendicular slope is negative 8/5. So everything else stays the same, just the slope changes. Writing the normal line, no problem if I found the tangent line already. I just have to change the slope, okay? So that's pretty much day 1 of implicit. Like I said, I kind of want to come back here for a moment and look at taking the derivatives of these things. Oops. Sorry. There we go. X minus 1, all raised to the, ooh, no they're not. Look at that. It helps to answer the question that's being asked, not the one that you think it is. That's a 3. Okay, so y prime. Go find y prime. Pause the video, come back when you're done. Let's take a look. Welcome back. So I'm going to just push here. Level dy. This derivative, I have to check. Don't forget to come back and take the derivative of the inside. Minus I d low. So the derivative of this is going to be 3, leave the inside alone, subtract 1, times the derivative of that inside. Okay, all over load squared. 4x minus 1 to the 3rd squared. Now we're getting close to chapter 5, so I think I'm going to take this a little further. And I'm going to do some of that GCF magic here. I can factor out this to the smallest power. I can factor out this to the smallest power. I can take out a 3. I can take out a 2. So 2, 3, 4x minus 1 squared, 3x plus 2 to the 1st. What's left over when I do that? By the way, raise a power to a power, you multiply. So what's left over when I do this? Well, I took out 2 of those, and I took out a 2, and I took out a 3, and I took out that, so I just have the 4x minus 1 left over. And then I have our subtraction symbol, and I took out 1 of these, so I still have a 3x plus 2. I took out a 3, I took out a 2, so I still have a 2 left over, and I took out both of those. So what's this going to be? 4x minus 3x, 4x minus 6x, minus 2x, 1, minus 4, minus 1, minus 4, is minus 5. So, oh, and I guess I can take 2 of those with 2 of those. So, my y prime then is 6x plus 2. Oh, yeah, I'll take that negative. All right, I hear you. All over 4x minus 1 to the 4th. Nice and tight. And yeah, very shortly now in chapter 5, we're going to be setting this derivative equal to 0. So we want this stuff in factored form so we can set each factor equal to 0. Setting the factors in the numerator equal to 0 tells me when the slope is 0, and setting the factors in the bottom equal to 0 tells me when slopes are undefined. And it turns out a big chunk of chapter 5 is very concerned with finding when derivatives are 0 or undefined. All right, so that felt maybe okay. How about this one? Y equals 2x minus 5 over 3x plus 4. Oh, but did I mention we've got some powers? Okay, so please find dy dx. Come back when you're done. You should really practice this. Don't just say, I can do that. I'm not going to do it now. Because what happens is, in another month, when that hasn't gone around and been practiced, it's so completely gone. And then when I tell you at the beginning of second semester, you're terribly, terribly, terribly dependent on your ability to take your derivatives quickly and accurately, but you've forgotten them all because you didn't practice it, it makes the spring so hard. So please practice this now. All right, y prime equals low d high Don't forget to take the derivative of that inside function minus high d low. Don't forget to subtract 1 here, and the derivative of the inside function high d low all over low squared. Now, if you hadn't already noticed, these are those really big GCF factoring problems that we saw last year in pre-cal, and they come directly from us using the quotient rule. So, yeah, I'm just going to leave it here. But, I do think it's worth practicing this factoring thing, because in chapter 5, you are going to have this, and you do have to be able to factor this. By the way, I might do that to make things a little easier for me. And then look, there you go. There you go. GCF factor away. Don't forget to tidy that up. And there'll be some of this on top and some on the bottom, and you can cancel those too. All right. So, last one. Y equals log base 2 of 3x over sine of x squared. Yeah, no kidding. I did that. You're welcome to say, what the hell is that, Googly? You don't expect me to take the derivative of that, do you? Oh, why, yes, I do. Yes, I do. Mostly because I don't want you to forget how to take the derivative of that log. Okay, so off you go. Maybe you have forgotten how to take the derivative of logs. Welcome back. Hey, so quotient rule. Y prime equals low d high. Derivative of this is 1 over stuff ln of 2 times the derivative of stuff. So, right, because let's rewrite this log base 2 of 3x using the change of base formula. So we have ln of 3x over ln of 2, and I could write that as 1 over ln of 2 of constant times ln of 3x. When I take the derivative of ln of stuff, I get 1 over stuff times this constant 1 over ln of 2. Good. And then don't forget to come and take the derivative of that inside function. Okay. Are we done? Heck no. I can't cancel those out. Minus high d low. The derivative of sine is cosine. Leave the inside alone times the derivative of the inside all over sine of x squared squared. This will not become x to the fourth. That would become sine squared x squared, right? I'm squaring this whole thing. So I just leave that alone and tidy this. No freaking way. Just walk away quickly, quietly. Don't anger. All right. I hope this was a useful introduction into implicit. I look forward to seeing you in our next video.